Hello everyone, this is Team Brainiacs. Myself Siddharth Dayalwal, Trushant Adeshara, Hemang Bhogayata, Rishabh Mann.
We are from Babaria Institute of Technology, Vadodara, Gujarat.
Our zonal center was SKIT College, Jaipur.
Our problem statement is Smart Irrigation Assistant for Farmers. So now I will be introducing you to the technological stack used in our IoT solution. So basically we have two parts, software and hardware. Let's have an overview on our software part. Firstly, we have Atmel Studio for programming our microcontroller, HTML CSS for front end, PHP for website backend, ThinkSpeak for displaying sensor data in the form of graph, Firebase authentication system for handling user data, and lastly MIT App Inventor for programming our Android application. Let's have an overview on our hardware part. Firstly, we have Atmega 16 microcontroller, USB ASP programmer, TTL, Wi-Fi module, humidity sensor, which are of two types, in soil and atmosphere, buzzer, relay, water inflow sensor, rainwater sensor, LDR, solenoid valve, and lastly temperature sensor.
So now let's have an overview on the hardware section of IoT solution. As you can see, we have made our own AVIA development board. We have soldered all the components together to get fruitful result. We have also kept a small PCB aside which we will be using outside the agricultural field. The purpose of this small PCB will be explained to you in the later part of the video. Also, as you can see, we have different types of sensor which we can use in a different manner. So let's install them on the AVIA development board and have a closer view. Getting the closer view, now let's get introduced to each and every component. It is a digital buzzer. It's an LDR sensor which we will be using for detecting the luminosity in the environment. It is atmosphere humidity sensor. It is a temperature sensor. In soil humidity sensor. We have used two pieces over here. It is a ULN2003 IC module which we will be using for detecting the level of water inside the tank. It's a Wi-Fi module, 16x2 LCD display, a rainwater sensor which we will be using for detecting the rainfall, a USB ASP programmer which is also called a loader. We'll be using this for programming the microcontroller. Over here we have a relay module, Atmega 16, 9V power supply, as all the sensors are consuming 5V and Wi-Fi module needs 3.3V. So we have also made a voltage divider over here which will be providing 3.3V from 9V. Over here we have a relay module and a rainwater sensor pre-installed. We have used Atmega 16 as our microcontroller. Let's get installed the other components. A digital buzzer. There are two in-soil humidity sensor. A separate PCB for temperature sensor, atmosphere humidity sensor, and LDR sensor. This small PCB we are going to place in the peripheral of agricultural land to note down the luminosity in the environment, the humidity of the atmosphere, and the temperature in the environment. Also we have a Wi-Fi module, a LCD display to display the values read by all the sensors. Here is a USB ASP programmer. This is a ribbon wire which we have already installed. Connecting this we can program our Atmega 16. This is TTL, transistor to transistor logic. We can program Wi-Fi module via TTL as well as via serial communication. We have ULN2003 IC. We are going to use this as a water level indicator inside the tank. So now let's give power to our development board. A 9V power is been given. So as you can see, all the sensors are working properly. The 9V is been converted to 5V using this transistor and been given to all the sensors. Also, the Wi-Fi module needs 3.3V, so for that we made a voltage divider using two resistors. These two sensors will be going to the soil, and this will be outside the peripheral of agricultural field. This will also be outside the peripheral of agricultural field. A relay module is used to start and stop the pump of the field.
Let us take an overview of our website. Here, as you can see, we have created a website for our Smart Irrigation Assistant. This website has been created using a front end of HTML and CSS with a back end of PHP. This website is currently being hosted by the 000 web hosting service. In front of us, we have a basic login form. A new user can easily sign up using the sign up button or even using Facebook, Twitter and Google, functionality of which will be added later. Let us take a sample. For user, say farmer1, let us enter his password. Let us log in. As the site loads up, we can see in front of us 5 graphs, namely luminosity, soil humidity, air humidity, temperature and rainfall. Let us take a sample of luminosity. Here we can see a graph of luminosity versus time. The data has been fetched from a ThingSpeak channel and will be represented in form of a graph with respect to time. As the project is under development, more values will appear as the project work proceeds for soil humidity, air humidity, temperature and rainfall.
Lastly, I would like to say that as you have observed, we have made a mobile application for the ease of the farmers. Means sitting anywhere in the world, a farmer can see the value of humidity, the temperature, the luminosity and the in-soil humidity, as well as the farmer can also see whether the area of the agricultural field is having a rainfall or not. And according to that, it can be managed by a mobile application, keeping it on a auto mode or by manually controlling it. So now we are trying to make it more user friendly, more feasible and more cost effective. So within a week or so, we'll be able to complete all these parameters and have a perfect device for the use of farmers, which can be easily implementable on their agricultural field. So thank you.